Okay, hi, good afternoon, everyone. We're going to get started. My name is Natalie Dean. I am faculty in the Department of Biostatistics at Emory University and a proud member of the American Statistical Association, or the ASA. And it is with great pleasure that I welcome you all to the 2024 ASA Invited Address of the Joint Mathematical Meetings. Today we have the privilege of hearing from our esteemed speaker, Dr. Katherine Ensor. Dr. Ensor is the Noah G. Harding Professor of Statistics at Rice University. She's a leading expert in applying computational and statistical analysis to track and forecast issues in public health, community informatics, environmental statistics, and computational finance. She was chair of Rice's Department of Statistics for 14 years, and she is currently director of Rice's Center for Computational Finance and Economic Systems. Dr. Ensor is a champion for statistics education, leading the development of many major education and research initiatives at Rice. Throughout her career, she has received many richly deserved honors. She is a fellow of the American Statistical Association as well as a fellow of the American Association for the Advancement of Science. Dr. Ensor was also recently the 117th president of the American Statistical Association. While ASA president, she established the Idea Forum to showcase how statisticians use statistics and data science to better understand how we live, work, learn, and play. With a wealth of expertise and a passion for statistical exploration, Dr. Ensor is set to enlighten us in her address today on how the foundations of statistics have and continue to make important contributions to modern innovation. Please join me in giving a warm welcome to Dr. Kathy Ensor.
Thank you, Natalie. That was fantastic. Thank you. Hi. It's wonderful to see you. I see a few people I recognize. Oh, hi, Michelle. Thank you for being here, and it's just an honor to be here to welcome you to the ASA Invited Lecture. Really excited that ASA is actually a partner in the Joint Math Meetings, and thank you for your attendance to my talk. And if you stay till the end, there is a reception this evening that ASA is sponsoring, and I'll give you the details of that, but I would love to have you all join us at that as well. All right, so I'm gonna try this style of talk. If it doesn't work, I'll move over to the podium. Okay, so this is a little bit of an ambitious talk. Equation free, except for maybe one. So, happy cube year. So I actually think this is kind of cute, but you know, you see the equation and then you immediately go to the R lingo. And I think there's actually a little bit of seriousness behind this kind of silly slide. But to bring home the point that we think in equations, we think in probability, we think in theory, but then we move into applications. And for statisticians, it's pretty much a seamless transition. And so much of the stuff that we do, we put it into action as quickly as we can, and that would be through R, Python, or Julia, or some other type of computing environment. Okay, so here's a little outline of my talk. So we'll start with quite a bit about ASA. I want to share with you some of the exciting things that have been going on. And then we'll move into sort of some different kinds of impacts of statistics and how we're being recognized. Talk about some innovations. Innovations means applications. And move into foundations, and then hopefully end with our takeaway. Okay. All right, so news from ASA. So first of all, you have time. You can even do it while you can multitask while you're listening to me. But the Symposium on Data Science and Statistics is in June in Richmond, Virginia. This symposia has a very long history. For the last couple of years, we've been trying to build it up as a feature where the invited sessions are refereed, and so that you actually have a refereed presentation if you get invited. And so the submission due date is January 8th. We do have one of the leading program directors from SIZE who will be speaking at the conference, so it's a great opportunity for people who like to think on the data science side. Okay, so another interesting bit of news from ASA that might be interesting to this community is that we have been working on this Data Science and Literacy Act. And so, this is an act that would authorize $10 million annually for educational activities in pre-K, K through 12, second and four-year colleges, and the goal is to get funding into the hands of educators and students to increase the development of statistics and data science, sort of the data literacy side, not necessarily the actual active side. So this has been introduced in the House, and it did have bipartisan support, and so we're currently doing the groundwork to try to get the bill approved. But this is the type of thing that ASA does take on, and it's quite an effort for us, so we're very proud of it, and hopefully it'll actually have some good outcome. So we also just launched the ASA Leadership Institute, so this has been something that has been a multi-presidential initiative, and it will continue with the next 3 presidents, and it's really to help our community have a bigger outreach in the world, as well as support our community in their leadership growth. So an example, so Natalie was kind enough to introduce the Idea Forum, and so the Idea Forum is one of our leadership activities. And so last year, the inaugural Idea Forum, we focused on climate change, and so IDEA stands for Influencing Discovery, Exploration, and Action. The annual, and it'll be an annual event. It's activity of the Leadership Institute, but it's sponsored by the ASA Board of Directors. And so Rich Sorkin is the founder and CEO of Jupiter Intelligence, and so he was one of our lead speakers, partnered with the CEO of Engine Number One, which is a not ESA investment, but that style of investment company, and then Noel Cressy, who is a leading voice in climate change from the statistics community, a global leading voice on climate change. And it ended up being a really wonderful, rich set of experiences and information. We're following that up with a series of workshops sponsored by NSF to ask ourselves, what do we as a community need to develop to be able to support how society changes as a result of climate change. So each of the Idea Forums will be followed up with a special issue of Chance. Chance is sort of the ASA's public magazine, so it's written for a broad audience. And so the February 2023 issue features this, the inaugural Idea Forum. And then this last fall, the current president of ASA, or president, the 2023 president of ASA, Dion Price, she chose open science as the focal point for her Idea Forum, and it was just simply wonderful. And so look for this, it'll be every November, and in next year it'll be AI. But in this fall one, for example, Peter Hotez was one of our speakers. If you haven't read any of his books, you really should, but he's just an incredibly strong proponent for the need for science advocacy, and I learned a lot just from the 2 hours of the Idea Forum, and I think each of you would as well. So some other things that the ASA does that I think are useful for you to know about. So we do have the Caucus of Academic Representatives. So we pull together all of the academic leaders to help promote the discipline, to give them support in their development, as well as successfully advocate for activities. So we've had that. I actually helped start this maybe 15 years ago at ASA, and it's been incredibly successful. So then as president, I mirrored that with creating the Caucus of Industry Representatives. And so this has been a hugely successful effort in pulling together sort of the manager and up people from our society. So ASA is 40% industry, 50% academia, and 10% government, roughly. And our presidents rotate through those three sectors. And so the Caucus of Industry Representatives is headed up by Ginger Holt. And I'll leave a question for you if you see Ginger again in my slides. So just watch for her. But she is in charge of forecasting at Databricks. Another example of what goes on in the Leadership Institute is our educational forum. So ASA has a lot of ongoing continuing education, but we're trying to elevate some of the things to be a regular offering that we do. And so for the last 5 years, we've been, Donna is the Associate Executive Director of ASA, and Ron is the Executive Director. And the three of us created this course, the Statistical Expert Witness. And so we've been giving this for the last 5 years we usually give it about twice a year. And it's really elevated the conversation around statistics in the courtroom. This is so critical because our science is in the courtroom. We need to be in the courtroom. And even more with the increased presence of AI in our social infrastructures, we need to be in the courtroom speaking for that science and not leave it to people who do not understand it. And so that's the goal of the Statistical Expert Witness course, but it's an example of what might go on in our Leadership Institute. And this has helped a lot in our profession because doing this is not for everyone and it's easy to make mistakes. And so the goal of this course is just to get people started and to make sure that they don't make those professional mistakes that some of us can. So, let's see. Okay, another example, this was started last year by Dion Price, is the Stats Forward effort. And so this is to provide early career statisticians and data science with mentoring and coaching, as well as to create future leaders of the American Statistical Association. And so it was a great activity last year, and we're continuing it this year. If there's any young people in the audience that would like to join ASA, this is a great opportunity to get connected. Okay, and speaking of creating the future, so I love this slide. So these are former PhD students of mine, and so it's really an awesome group, isn't it? I mean, it really is. Do y'all recognize anybody in there? Anybody? Ginger Holt, there you go, great. So Ginger's in there, yes, and she's done incredibly well. Anybody else? Someone who regularly speaks or was a featured speaker last year at this meeting, and her book was just on the slide of our previous speaker. So third row middle, Talithia Williams. So maybe I should make her picture huge to go with her reputation, but I am honored to call Talithia one of my previous PhD students. And then if you go to the top row, I'm going to embarrass Julia a second because she's in here. So Julia Shedler, top row. So Julia's in the room. I'm incredibly excited to have her here. And I'd like to give a round of applause to Julia because she has just accepted a position in the academic world in California. I won't be more specific, but let's congratulate her. So. And yes, I did sufficiently embarrass her, I think. But Julia is actually working with me as a research scientist now on this wastewater epidemiology stuff that I'll give a little bit of a heads up to. But I hope that when you look at this set of students, maybe it's not clear from their pictures, but there's a lot of diversity in that group. And diversity not only in background, but diversity in the way that people think. And so I was really honored to be in the previous speaker's talk, listening to how we should be educating a broader group of people. And thinking, reflecting on that, I've had that opportunity because each of these individuals come to me with different backgrounds, but also think differently and have all gone on to superstar careers. And it's, me more not getting in their way and just helping them a little bit than anything else. Okay, so, all right, how many, are y'all mathematicians, statisticians, data scientists, mathematicians? Okay, data scientists, statisticians? All the statisticians are listening to Kim. She's next door. Okay, so CSAB, so it's the Computer Science Academic Board, and this is something else that ASA ventured into over the last few years, and it's actually incredibly important. Any of you heard of ABET? Know what ABET is? So ABET is the accrediting organization for engineering. Okay, so ABET proceeded to begin this effort of accrediting data science programs. Okay, and they were going forward with that without any statisticians or mathematicians involved. It was pretty much a computer science effort. And so as they went down this path, they realized that they needed us in the room. So ASA has formally joined the Computer Science Academic Board, and so we're part of the Computing Accrediting Association, which means we also give advice on other areas of computing. But most importantly, we were able to help guide the accreditation criteria in data science. So that criteria exists. So this is an ABET accrediting organization. And so if you're developing an undergraduate program, a master's program, or a community college program, and you want it accredited, the mechanism is in place, and the accreditation is global. And so I actually think this is important. We're spending a lot of time and money this direction because it is seeming important. Okay, another new thing from ASA. We've just acquired a new journal. This is Data Science in Science, and so this is now going to be part of the ASA journal offerings. Super excited about this. David Madison at Cornell is the editor, and you can see all these special editions, but you can see that bottom one. That's my next week's task, is to get him a proposal for a special issue on wastewater epidemiology. So this is proving a very important journal. So it's been in existence for 3 years, and by it becoming an ASA journal, we're hoping to really elevate it to one of the top ASA offerings. Okay, so that's it about ASA. Was that worth your time? Okay, got some nods. All right, so let's talk a little bit about recognizing statistics and statisticians. And there's no Nobel Prize in math, right? Is there a Nobel Prize in math? No? Okay, there's no Nobel Prize in statistics either. And so somehow that we need to fix that. And so we can't fix that directly, but we can do some things around that. And so we brought about some new opportunities to recognize statistical advances, and again, with the goal of bringing international attention to the contributions from our field to the betterment of science and society. So I'm just going to briefly talk about 4 of these. So the first is the International Prize in Statistics. So it's been awarded 4 times. Do you recognize any of those names? Sir David Cox, Brad Efron, Nan Laird, C.R. Rao. So these are some of the leaders in our field that really have helped transform sort of statistics to the space that it is now. And so this award is given every other year, and again is considered one of the top awards in statistics. And then in 22, Peter Roseo, who is a statistician, he works in robust statistics, but he joined Wall Street, maybe 20 years ago, and did quite well for himself through that, and was one of the central figures in one of the big high-frequency trading firms. And so he has actually started something that would parallel a Nobel Prize. So it's $1 million prize in statistics. It is offered every other year as well, opposite the international prize. So these are two different efforts. The thing about this prize is he's going to move it around the world. So the way that he set it up, it has to go to different parts of the world each year. And the very first prize did go to James Robbins and his colleagues for causal inference. So if you're aware of what is going on in the statistics community now, you know that causal inference is one of the big areas of our field. Okay, now this isn't a statistics award, but it's worth letting you know that these awards, that these are people that are engaging with the statistics community. So Cynthia Rudin is a computer scientist, and she won the AAAI Squirrel AI Award. And as president of ASA, I was writing a letter for her nomination. Happy to do so. She and I intersected at the National Academy's effort. But Cynthia is very active in the statistics community, even though she comes from the computer science side. And she's helping to define what transparent and fair AI looks like. Okay, another example of statisticians winning big recognition is Robert Engel. If you probably may not know Engel, but he did win the Nobel Prize in economics for the development of the GARCH and ARCH models, which is a time series technique that I teach regularly in my classes, for example. But I want you to notice that in 2003, he gets the Nobel Prize. But in 2000, more importantly, he became a fellow of the American Statistical Association. So it's, the message behind this is our association in our field draws strongly from other disciplines, and we're a great place for people to interact. Okay, so now let's go to the focus of this talk, which is innovations. And I'm just going to be hitting some things that you may not be thinking about. You know, we're all contributing to self-driving cars. We're all contributing to personalized medicine. So some of these, we're all contributing to the advances in brain science. But maybe what I've chosen to highlight are some things that maybe you might not think are going on that are going on. So one thing is forensic science. So there's a large group of statisticians that they're contributing to elevating the discipline of forensic science, bringing the science back into the data analysis. And so Maria Kular is an excellent leader in this area and has a paper on implementing blind proficiency testing in forensic laboratories. And then CSAFE is a large organization that is center that Alicia Carriqui oversees. So this is very important work that has very strong consequences for our society. And then, as I mentioned before, Cynthia Rudin, she's leading an effort in interpretable and transparent AI. That's the focus of her work, but it's also the focus of many in our community. So a lot of our energy and efforts go this direction. Okay, so near and dear to my heart is the area of community analytics, where I've been working for the last 20 years. And so the idea here is that we're bringing the best of our science to collaborate with municipal or state governments, universities, local businesses, NGOs, and community organizations to help elevate the science that goes on behind the decisions locally. And I'll give you some examples of this. But first, let me give you a couple of examples from the National Academies, Michelle. And so there's Enhancing Urban Sustainability with Data Modeling and Simulation, proceedings of a workshop that was held in from 2019 to 2020. And then in the summer of 2022, there was a follow-up, Enhancing Urban Sustainability Infrastructure, a workshop on mathematical approaches for optimizing investments. And Jean Holm, who leads sort of the LA effort in this space, headed up that effort. So these are really good places if you're interested in this space to get great information about what's going on. So let me talk a little bit about just my own work. So in the community analytics space, just briefly, so air quality and health. So this is an area where I've been contributing my time for quite a while. And so some of the outcomes of that, and my goal with my work is that it has action, that it's not just publications, but I'm able to work with city officials or county officials or state officials so that my work gets transferred into action. So for example, we quantified the joint impact of ambient pollutants on health endpoints of cardiac arrest and asthma exacerbation. And so this is very much a large data project. And through that, we were able to establish city-specific air quality alert systems for asthmatics. And so by having this daily email that goes out to the list that signs up for it, people get immediate information on the conditions for Houston. And so this is different from what EPA would do for the Air Now effort, which is a global look. So we were able to look specifically at the conditions for Houston that drive challenges for asthmatics. We also work directly with the school nurses in Houston to elevate this science and to help put into place a plan for dealing with students that are asthmatics, and this reduced the incidence of asthma exacerbation in children dramatically in Houston. And so that's an example of community analytics where we're bringing, and this is not minor science, this is major science, cutting edge, using the best of our science to answer these kinds of questions and then providing those answers in real time to people. And then as many of us in the statistics profession and probably mathematics as well, so COVID required a lot from all of us. And so two things that I did specifically to help Houston, we immediately started this prevalence sampling effort to understand what the true prevalence was in Houston. So I was super excited because as a student, way back in the day, I studied sampling. And so I got to use my sampling design to design this sample for Houston. And so we went out to the homes of Houstons. We asked them to give blood. And from that, we were able to nail down what the prevalence was in Houston. And this was not known at the time. And so this had dramatic consequences on the mayor's decisions on how he managed the pandemic in Houston. And so the prevalence was basically a factor of 4 over what had been estimated from sort of the data science approach. All right, so then that led into, well, okay, that's great, but that's hard to do. We're not going to regularly go out and take blood from people. I mean, that was a very expensive study, and thank you to all of the people that donated who were willing to let us do this. So it turns out that our cities and our communities, the wastewater in our cities and communities, have a lot to say about us. And at Rice is one of the leading wastewater epidemiologists. She's an assistant professor in civil engineering. And so we had the opportunity to put a team around her. And so that's what we did. And so So here's our team, and there's actually a website, so I won't go into this too much, but it's Houston Wastewater Epidemiology, and Julia is working with me on this until she takes her faculty position. But what you see up those top graphs, that's the snapshot from Friday. So the top curve on the time series graph, that's the estimate of what's going on in the city based on wastewater. And so you see that we're kind of in a little bit of an uptick right now with COVID. And then the bottom time series plot, the blue one, that's actually the COVID test data. And so you see that it no longer exists. So we're no longer in Texas, are we measuring COVID tests. So that data is no longer available to us. So wastewater is really all we have right now to understand the prevalence of COVID in our community. And it doesn't stop with COVID, so you can measure any kind of viral disease or HIV or drug use, so there's all kinds of things that can be measured in wastewater. And I'm very proud of this work. It has been going on a while, so this is a lot of effort. We still have weekly meetings, and we are a CDC Center of Excellence for this. There were 2 initial ones. We were one of the 2, and now there's 6 across the country. But David Purse, who is the Chief Medical Officer for the city, the 4 of us, our executive team, myself, Lauren Hopkins, and Lauren Stadler, recently received an award for this work. But when we received the presentation of this award, and he stood up to give comments because he's like the most prestigious person of the 4 of us, but he turns to us and he says, "This team saved lives." And so I feel like we did, because a lot of and this is bringing the best science, not 10 years ago science, but cutting edge science to society immediately. I feel like we did offer answers that the city could act on that helped dampen the pandemic in the Houston area. Okay, all right. So climate change mitigation. So Bo Lee at the UIUC, she and her colleagues have a generic risk assessment framework to evaluate historical and future climate-induced risks for rainfall, corn, and soybean yield in the U.S. Midwest. And so this is an example of the type of impact our community is having. And if we think more broadly about climate science, so remember I said Rich Sorkin spoke in our idea forum. He's the CEO of Jupiter Intelligence. He's also the one who founded Kaggle, so maybe you know him a little bit better from Kaggle. But Steve Sain is a graduate of our program a long time ago, but he's the senior data scientist at Jupiter Intelligence. And I asked him for some thoughts on this. And so, we're no longer, I think, for the most part, we're really not arguing too much about human-induced climate change. But we are seeing the more frequent storms, the more frequent impacts. And the question is, now what can we do? And so I really like Steve's takeaway. So just like we've made huge advances in biomedicine with a public-private partnership, the investment in our health, we need that level of investment in our mitigating the impact of climate. So we need that private and public entities collaborating to really move this forward. And from the statistics side, many of us are working on the climate risk analytics space, as, for example, Bo's previous slide. And I'll give a little bit of my own as well. But the important thing, just continuing with Steve's insight, so these are huge models. This is huge. So this is computing, even doing small things billions of times takes a lot of time. So we have to think strategically about how we're going to advance our science to support the mitigation of climate change. And so that's the conversation, is how do we adapt society? How do we help society adapt to the climate change that we're seeing? And so here's my story of how I helped. So again, going back to my community analytics, I do live in Houston. Houston has a great space for all of this because there's lots of opportunity to contribute. And so this is actually a picture from Hurricane Harvey. You may not remember Hurricane Harvey. Those of us in Houston probably do. But we use the phrase managing floods, learning to live with water. So we know that we're going to have floods. How can we make sure to do the best with it? And so if you look at this graph, so this is 100 years worth of data at different locations, and every line is a daily measurement. The first, anything below an inch is not included, so this is everything an inch or above. What's important about this graph are those purple lines. So those are the levels, those are the 100-year depth levels for the flood. So in general, we would not expect to see observations above the 100-year floodplain. This is 100 years of daily data, but we do. So the red areas, that's a flood. So every time there's a red event, Houston has flooded. And so going back to landing on the moon type lingo, Houston, we have a problem. So the question is what do we do? And so what did we do? So we were part of the conversation on redesigning the building codes in Houston because we don't want to continue to have to rebuild homes and fix homes. So as we look forward, what can we do? So we were teamed up with the civil engineers that were helping Houston make the decisions. And so we were asked to really assess whether rainfalls in Houston were increasing. And you think that that's an easy question to answer, but it's actually not so easy. And we were also asked to do it for each region. So you have a blue region, a red region, and a green region. So those regions of our city are hydrologic regions, and so those are very important from the flood modeling perspective. So I'm trying to work with the civil engineers for their flood modeling, and so they design the question for me, and then I see if I can answer it. And so this ended up being a key layer in the flood modeling prediction for Houston, and it informed the new building codes for the city. And if you look at my bullet point number 2, so we not only wanted trends for the region, but we wanted their certainty quantification. You usually think of that as uncertainty quantification. I'm trying hard on this rebranding. We're branding it as certainty quantification. How certain are we of our estimates? And so I've got 3 pictures here of the trends, and they're color-coded, so the red goes with the red region, which is basically the center of Houston. And so what you see in those time series plots, and there's only 3 points plotted, but hopefully you can envision sort of what it would be to fill in. So those are the 25, the 100, and the 500-year estimates of where we are with rainfall levels at this time. And so there has been a dramatic increase in the level of rain in the central part of Houston, in the northwest part of Houston, but maybe in the green area, not so much because that includes Galveston, and Galveston has always had sort of this heavy rain, these heavy rain events. Okay, so community analytics, how can you have an impact if this is something that you're interested in? You're gonna answer, first of all, you have to answer the questions asked, and then you have to answer the questions on time. And then when do you engage? Well, I'm going to engage when there's a chance that I myself will have a real impact, and that I bring unique and important knowledge to the question. So leaders in statistics are tackling these types of challenges, and we're always looking for opportunities for what we can do better together, and I really thank the National Academies for their efforts and leadership in this way. Okay, so just really quickly, because I think these are interesting examples. If we move to imaging, this is a space where many in our profession are spending a lot of their time. And you can think of all kinds of issues around imaging, personalized medicine, medical imaging, mapping our brain, robotics, remote sensing. So the statistics community spends a lot of their time in this space. I'm going to pull out one example, and this is from Anu Srivastava from Florida, because I think it's an example maybe you don't necessarily think about. But what he's done is he's developed statistical strategies for understanding retinopathy in individuals. And so I myself have benefited from this. So I'm paying for that extra scan now so that I can get a digital image of my eye. And so we're able to separate sort of the individual subjects, the average shape, and then understand if an individual is different from the norm. And so this is work that actually goes straight into practice, and it's great stuff. I'm going to actually skip the finance piece because we're kind of low on time, but it will be in the slides if you are interested in that. So let me move to foundations. Point you to a 2017 paper in the Journal of Computational and Graphical Statistics by David Donahoe. So the title of the paper is 50 Years of Data Science. So the SDSS conference that I pointed you to at the beginning of the talk, that conference has been going on for over 30 years. And so that is a conference that has brought together statisticians, mathematicians, and computer scientists for over 30 years. It's been rebranded in the last few years, but the history of the conference is 30 years old. And so just going to a quote from Donahoe, drawing on work from Tukey, Cleveland, Chambers, and Bryman, he presents a vision of data science based on activities of people who are learning from data, and describes an academic field dedicated to improving that activity in an evidence-based manner. So data science has been an area where statistics has been one of the prime contributors and developers for over 50 years. And we love it and excited to be engaged in it. If we move to a 2021 paper, so let me point you to this one, in the Journal of the American Statistical Association. So this is by Andrew Gelman and Avi Vaturi, and it's what are the most important statistical ideas in the past 50 years. So let's just take some time to read these bullets. So generic computation algorithms. So yes, we're all writing algorithms, and how well can we make them? Bayesian multi-level models. So that's where many of my colleagues and myself, we spend a lot of time there. Gaussian process modeling is sort of reigning supreme at this time. Then if we move away from the Bayesian perspective, we have the overparameterization, models and regularization. So that's the sparsity type thing. And then counterfactual and causal inference. We saw that there was an award given for that. Bootstrapping and simulation, so that's, Brad Efron received an award for that. Robust inference is what drove Peter Rousseau's efforts in being able to start the Rousseau Prize. Adaptive decision analysis, so if nothing else, think clinical trials, adaptive clinical trials. And then something that we all love, even though many of us do, exploratory data analysis. What can we just learn from the data by graphing it and just exploring it? And then what do I think is missing from that? So, in my rainfall example, I needed extreme value modeling. It's a very rich area. There's actually a journal called Extremes, and I draw from that regularly. And so my phrase is standing on the shoulders of giants and trying not to slip, because it's a very hard field to apply. If you're interested more, their ASA has put together their editor's choice. And so just go to amstat.org and you'll see this. And I'll just highlight 3 of these. So this first one on the left here, this is looking at air quality and health. And then the middle one, so this is an online quality control for topological data analysis. I just directed a dissertation a couple of years ago in topological data analysis, so that's a good marriage between mathematics and statistics. And then as another example, statistics and public policy, we have Andrew Gelman looking at sort of our political landscape and how states have flipped from a Democratic to a Republican and vice versa. So it gives you some breadth of what we see in our journals. Let me just skip over this. So moving to open source software, so that's critical to we consider that a foundation. And hopefully you find yourself somewhere in this space. My little red line there, Python is now accessible through Excel. So that's really going to change the landscape a little bit. I don't use Excel, but many in the business community do. I'm an R-posit person, so that would be my space. But underlying all of this is data. Data is really the foundation of our message. So data can be transitory versus permanent, authentic versus fake. We care a lot about data privacy. We think a lot about massive, large data. But then in my examples that I've given you, the data is neither massive nor large, it's complex. So we can't leave out these methodologies to deal with these small data sets or these very complex data sets. We think of observational studies versus designed experiments. So my example of COVID prevalence, where I'm designing the sampling frame for the city, that would be an example of a designed experiment. And then we should all be thinking hard about representation of our data. So without that representation, anything that we build on that doesn't matter. And so I will point you to the ASA ethical guidelines for statistical practice about integrity of data and methods, basically saying as an ethical statistical practitioner, we need to know what we're doing and we need to be upfront with the limitations of what we have done. It's probably worth you knowing that the US Census Bureau now has 3 ASA presidents in its leadership. So Rob Santos was the ASA president preceding me, and he's the director of the US Census. Sally Keller, she's president from a while back, but she is leading the research team at Census. And then Wendy Martinez is leading the data science team. And so, so they have a huge effort to bring let me just go to that last slide. So there's a great article. Census Agency aims for a better statistical snapshot of the U.S. So that's in Science, May 2022. And so there's this big push to really, how can more of our data sources be used to answer bigger questions. And the bottom line, science will carry the day for these answers and not politics. And so I'm just super excited for all 3 of them and for their contributions that they're making to our country. I think these are just slides that you can go through if you can download these slides, but they're just details on each of the things that I've previously alluded to, and I do want to leave you time for questions. So statisticians rock. Yep. And so the ASA mission, promoting the practice and profession of statistics. So I hope that I've given you some examples of how statistical foundations do drive 21st century innovations. But these innovations are broad, and informed ethical practices are key. And so we've brought forward the Leadership Institute and the Idea Forum, which is both an outreach and an in-reach. And then, sort of the goal that statistics plus science plus the public will equal better solutions for our communities. And as always, everything that we do really does matter. Mathematics is core to sort of a sound society. So the ASA vision, a world that relies on data and statistical thinking to drive discovery and inform decisions. So I would just add to that, let's bring a healthy dose of skepticism to our decisions that we bring forward. Only we know sort of the pitfalls of what we might be saying. But most of all, let's use our voices to stand up for statistics and for mathematical sciences more broadly. And even more broadly, let's stand up for science. Going back to Peter Hotez's message, we really, as a community, need to do this. And by standing up for science, we are standing up for society, and society needs our voices at this time. So with that, maybe you would like to join ASA, become a member. So let me go back. It's an amazing community. This is my equation number 2. So I started with an equation, I'm ending with an equation. But we're in an amazing community that tries to do a lot. We're very welcoming. You can see that we interface with many different disciplines. And maybe you'd like to join us. And with that, come and hang out and party with us at 6 o'clock this evening. And so there is a reception in the Marriott Marquis Pacific 1. And if you want a copy of these slides, that's what the QR code will take you to. And with that, I'll stop and say thank you. And take questions. If you have questions, maybe go to the mic. So. That exciting. Alex is going to be brave.
So do you have any idea why the data scientists underestimated COVID prevalence so badly?
Okay, so are you talking about my comparison with the Houston data, or are you talking about more broadly?
Well, you said the old one was 4 times under, and I'm curious if you know what they did wrong.
So the estimate was just based on testing and what came in through the state. And so basically, people were having COVID at home. So you know, if it didn't come in through the state, then it didn't get recognized. And so that's pretty much the reason, yeah. Okay. Yeah, okay. Other questions? Okay.
Great. Well, let's thank again our speaker for a wonderful overview.
Thank you.
Of so many great activities. And as you can see, we'll leave the information up about, I hope you can join us at the ASA's invited address reception this evening at the Marriott Marquis. Thanks, everyone. Have a great afternoon.
And thank you, Natalie.